Hi. In this project, our goal is to develop and validate two machine learning models to predict hospital charges for various services. This is important because accurate prediction of healthcare costs help hospital optimize their resources and make informed financial decision. For this analysis, we utilize the support to the dataset, which contains a range of patient demographics, clinical features, and other health-related data. The target variable we are focusing on is the charges, representing the cost of services of each patient. The two models we will use are the decision tree regression tree and the light GBM Ensemble model. The decision tree regressor is a simple tree-based algorithm that splits the data sets into subsets based on feature values, aiming to minimize the prediction error. While it's straightforward models, it provides valuable insight into decision-making rules. On the other hand, the light GBM model uses gradient posting where multiplied decision trees are built sequentially to improve the accuracy of prediction. This model is particularly efficient when dealing with a large data sets and can deliver better results for complex tasks. We will evaluate both models using the mean square error MSE, which measures the average square differences between the predicted and actual charges. A lower MSE indicates the model has performed better by providing prediction closer to actual values.
So to assess the performance of the like GBM model, we first look at the learning curve. So the learning curve plots the MSE for both the training and the validation tests as the size of the training data increases. The curve shows that the more data is fed into the model, the training MSE decreases, which is expected. However, the validation MSE initially drops but begins to stabilize after a certain point, indicating that the model reaches a point of diminution. Returns where adding more data doesn't significantly improve the model's performance. This observation suggests that the model is generalizing well and is not overfitting to the trained data. The second analysis we perform is a comparison of actual charts versus predicted charts. In this plot, each point represents a patient's actual charts and the charts predicted by the IGBM model. The closer the points are to the red dashed line, the better the model's predictions. In this case, most of the points lie close to the diagonal line, which indicates that the GBM model has done a good job indicating the charts. This is a promising result and demonstrates the model's effectiveness in forecasting hospital costs. In conclusion, by the end of this analysis, we will have compared the performance of both models and determined which one provides most accurate predictions for hospital charts. The learning curve and the actual versus predicted plot will help us to identify any areas of improvement and guide us in refining the models further if necessary.